Hello everyone, my name is Nick Bassill. I'm at the University at Albany. I'm the Director of Research and Development at the Center of Excellence, part of the UAlbany Weather Enterprise, and I'm going to give a somewhat brief retrospective of Isaias and the damage and impacts that it caused in New York, specifically from a weather perspective. This briefing is meant to be used by state agencies or authorities or utilities or any other interested party who is intrigued by what happened by the storm and the forecast challenges for it. So with that, I'm going to start by jumping to the end, just give a really brief highlight of what happened based on New York State Mesonet observations. For those of you who don't know, the New York State Mesonet is a $30 million weather observing platform installed about 5 years ago that is state-of-the-art and best in the nation. So the peak wind gusts are displayed here for the day of Tuesday ending at midnight on Wednesday. And you can see that areas in New York City, Long Island, Hudson Valley saw the strongest winds with peak winds of about 70 to 75 miles per hour in the New York City and Long Island area, and then dropping off pretty quickly as you move northwestward. And if we look at precipitation, precipitation totals peaked a little over 5 inches. They're pretty widespread 3 to 4 inch and 4 to 5 inch areas, but you'll notice that the precipitation was a little bit to the northwest of the peak wind gusts. So the area of highest precipitation was northwest of the area of peak wind gusts. So before we touch on that a little bit more, let's examine what happened with the forecast, what we knew when we knew it, and so on. And then we'll go back and look at the actual specific details of what happened in each location. So what I'm going to do is jump through a couple of key points, trigger points, I guess, and I'm going to show the National Hurricane Center forecast on the right, and then the New York State City Area National Weather Service Office, their most relevant tweet corresponding to the image on the National Hurricane Center track, just to highlight what was maybe being said publicly at the time. So this one is the first time that New York, any part of New York, would be considered, quote, in the cone of the forecast track. So what this means is that the National Hurricane Center, they issue a track, and you'll see the little the black line here and the different dots that correspond at different times. But they also issue a cone, and that cone is meant to display some amount of uncertainty. So the way that it works is historically 2/3 of all storms' final position has been within that cone at that time. So then you can think of it as 1/3 of the time storms end up going to the left of that track, 1/3 of the time they go to the right, and sometimes they go so far to the left or right that they're not even in that cone, although that's rare. So in this case, you could think of it as 1/6 of the time storms would go to the left of the far western edge of the cone. So at this point, on 5 p.m. on Thursday, this is basically the first time any part of New York is in the cone, although the storm track itself is still pretty comfortably off the coast. Jumping to Friday at 11 p.m., this is the first time that any part of the forecast track was forecast to cross any part of New York. And at this point, you'll notice that is forecast to occur at about 8 p.m. on Tuesday. You'll see that the cone itself is now shifted, so say Albany is part of the cone right now. The National Weather Service report highlights potential heavy rain, and that's really the biggest impact they highlight. They suggest a chance of tropical storm force winds. Now if we go to Sunday at 5 a.m., what this is showing here is that this is the first time the forecast from the National Hurricane Center has taken a track west, or just barely west in this case, of New York City. So this, just for reference, the storm impacted us on Tuesday, so this is about a 2-day lead time for something like that. You'll notice the cone likewise has continued shifting. Now the local weather service office has continued upping the risk of tropical storm force winds up to a 30 to 40% chance, and they're still highlighting the risk of rain 2 to 4 inches. Now the final one, Monday morning at 11 a.m. And this is the first more or less accurate path. And I note path and not track here because you'll note that the 8 p.m. position here forecasts the storm to be, say, just south of Albany, just north of New York City. In actuality, by 5 p.m. on Tuesday, the storm was already over Albany. So even though this is about a day ahead lead time with the right path, the storm sped up after this. And also note that the storm hasn't even made landfall across the Carolinas yet. So there's a lot of area that was impacted in the U.S. in a very short amount of time from the storm, which impacted the ability of New Yorkers and people in the Northeast to maybe gauge impacts by what happened further south. So at this point, the local National Weather Service office is really highlighting the risk of coastal flooding, potential for tropical storm force winds based on tropical storm watches and warnings, and heavy rain is also noted here. So if we just kind of zoom in to those threats here, you'll see in the upper right, they suggest at this point, so again, this is Monday morning, a large swath of rain over 3 inches from New York City into the lower Hudson Valley, and then tropical storm watches and warnings for pretty much all of Long Island and New York City. And then the upper left has their best guess of kind of a situational overview, as they say, possible impacts around the area. So I want to highlight just, this is not a National Weather Service product, but this is the products that we put out here at the Center of Excellence that are available to all utilities in the state free of charge. And we try to highlight as much possible relevant data as possible for each utility in each geographic area, and condense it in a way that is hopefully easy to read and pretty intuitive. So I'm just going to highlight 2 areas and how they looked Monday morning. So this would have been, more or less as you were looking at that last National Hurricane Center forecast track. What would the forecast have looked like if you were looking at it on here? Now I'm going to highlight the New York City area and the Hudson Valley area, but I want to note that just because we're doing so, that doesn't mean that we're implicating or suggesting that any organization should have done one thing or another in those. This is purely a weather discussion here. So looking at New York City, the way to read this is on the right, there is a table, and you can, I'm going to get my cursor here, you'll pick the thing that you care about, so say wind gusts right here, and then you'll pick the quantity that you care about, or the threshold, so say 50 mile per hour gusts, and then you would then take that variable and that time and follow it over, and then see if there was a chance of that happening. So basically what this says is, if you care about wind gusts, 50 plus mile per hour wind gusts, there's a high chance of that happening in New York City between 2 to 5 p.m. on Tuesday. That's how to read this. So the map on the left just gives you a map view of what the most probable peak wind gusts for any given period. So this is just what we'd say is a deterministic forecast, and not a possible like the table on the right is. But this says this orange is 50, and then the darker orange here is 60. So you'll note that there's kind of in the 50 to 60 plus range on the afternoon of the 4th or evening of the 4th. So looking at a total accumulation, here that the table on the right is the same, the map on the left has changed total precipitation, and so the yellow here is an inch plus. And so you'll note that in this particular forecast, it's less enthusiastic about heavy rainfall over or just north of New York City than the National Weather Service forecast was before. Doesn't necessarily mean one is always right or one is always wrong, but in this case, this ended up being a little bit more accurate of a forecast. So looking up what happened in the Hudson Valley area, again, this is a 2-day look ahead from Monday morning. So the same setup, table on the right, and then a map of wind gusts on the left. you'll see that there's a chance of 60 plus mile per hour winds. So I'm following the 60 over here, and then there's a low chance. So not a great chance, but a chance of that happening in the Hudson Valley again Tuesday afternoon. And then if you look over here at the map, you'll see that these oranges are the 50 expected 50 mile per hour gust contour. So that just kind of cuts across the furthest south and southeast areas of the Hudson Valley. However, looking at rainfall, you'll notice that there's a much greater chance of heavy rain. There's a chance of up to 4+ inches of rain. So I'm saying precipitation total, looking down at 4+ inches of total precipitation, following that over, and I see, hey, by 5 p.m. to 8 p.m., there's at least a chance of 4+ inches of rain. And then looking at this map of running total precipitation, I see that yes, indeed, the northwestern parts of that territory, that area, I should say, have some of these darker reds, which indicates 4+ inches of rain is expected. Okay, so that's kind of the quick and dirty setup of the forecast and how it changed over time. So let's look at a detailed analysis of what actually happened. And for this, we're going to look at New York State Mesonet data. So first of all, just where did the storm go? And so this is a map of the minimum pressure. And so you may know that storms are measured by their sea level pressure. And so this is basically saying what's the lowest that was at any place in the state, or at any time in the state over the course of that day. And then let's map that. And so this, you can see this area of lowest pressure here is basically the storm track. And so we're going to say, hey, we know that is a storm track because of this map. And remember, this ended up being well to the west of some of the earliest National Hurricane Center forecasts, and is more or less equivalent to what actually ended up happening, or was actually forecast as of Monday morning by the National Hurricane Center forecast. So just a different way to look at peak wind gusts. They're to the right of the track here, and the thing to note here is this was always going to be the case. In northward moving tropical storms and hurricanes that have any kind of speed, the peak winds are always to the right of the track, and heavy rain is always to the left of the track. And that's true in probably 90 to 95% of cases, and this one was no different. But the key thing here is that then that meant that where the track was exceedingly important, because in this case that meant peak winds were going to be over New York City. If the track ended up going over New York City, that meant that peak winds would probably be on the eastern tip of Long Island, and New York City and the lower Hudson would maybe be in the heavy rain area. But with this track right here, that meant that the heavy rain was going to be over the Catskills or maybe Albany, and not, say, the lower Hudson Valley or New York City. So track ended up playing a huge role here. So let's break down why there was so much damage in New York City and some nearby areas. So what I have here is some data from 8 p.m. Monday to 8 p.m. Tuesday. And there's an animated loop of the radar on the top left from that exact same period. And then I've circled the area that we're looking at. We're looking at the Queens New York State Mesonet site. And what I want to highlight, what I really want to focus on almost all of these things is the wind. And so the top right plot, these dots correspond to observed gusts. And so that scale is here on the left. So this dot right here would correspond to about a 70 mile per hour wind gust. Down here is what the direction of the wind was at the time. So west, so this would be a west wind, this would be an east wind, this would be a south wind, and then this means that this would be, say, a southwest wind. So a couple things to note here. One, that there were many very strong wind gusts. You can see, using this 50 as an arbitrary threshold, there are many, many, many dots above 50 and some approaching 70. So there's really a lot of big wind gusts. So that's one thing. There's a long duration of 40 plus mile per hour gusts. So if we again use 40 as another arbitrary threshold here, that's basically from the left edge of this rectangle to the right edge of this rectangle, and all of the rectangles are denoted by time here in the lower left, in this case 10:30 a.m. To 3:30 p.m. So that's about 5 hours of 40 plus mile per hour winds. Now, a hidden thing that may go unthought of for many people is that these winds were occurring from many different directions. So you'll notice that during this whole time, the wind was continuously changing direction. So they started off from the east and they ended up in the west. And so basically you got extremely strong wind gusts from many different directions over the course of the day. So if you had a tree that was vulnerable to easterly winds, but maybe not southerly winds and not westerly winds, and then vice versa with a tree that was vulnerable to southerly winds, both of those trees would have been impacted in this example here. And then finally, it's extremely rare to see southeast winds that are this strong. So these peak winds here, 70 miles per hour, is coming from basically the south-southeast. That is extremely rare for a place like New York City. So how rare are those? Well, we actually have a good way of knowing how rare they are because the site's been operational for several years. And so we can look at what is the likelihood that a given wind gust will happen from a given direction. So this table, or these sets of tables, highlight the entire range of wind speeds from each, in this case, of 8 possible directions. And then the percentages here say if you lined up all of the wind speeds or wind gusts from that exact direction, what would be the 5th highest, or the 5th percentile highest wind gust, or the 50th percentile, or the 99.9, so basically right at the top. So how to read this is 99.9. If we're going to look at how often do the winds come from the southeast, we'd say, okay, southeast, we'll follow that over. Hey, only 7% of the time in Queens do the winds come from the southeast. That's pretty unlikely. And the 99.9th percentile peak wind gust, when that happens, is 44.8 miles per hour. Yet, they had many wind gusts from this direction above that, including up to 70 miles per hour. So basically this is saying that this is an extremely unlikely wind speed and direction, which in combination can really stress lots of trees and other kinds of infrastructure. So let's just do that same analysis and a little bit quicker now, but for other sites in the area as well. So looking at the Wantagh site in Nassau County. So this is near the South Shore. Again, they had peak wind gusts about 70 miles per hour. They likewise had a long duration of 40 plus mile per hour gusts, in this case about 6 hours. Similar to Queens, but not quite as impressive. They had a wide variety of wind directions from the east-southeast to the south to the southwest. So that's about 130-degree range, basically a third of what's possible. And again, they had very strong southeast winds, which are pretty rare. And now I'm going to go a little bit faster here, but they only have southeast winds about 9% of the time, and only about 1 in 1,000 times when the wind is from that direction is it over 38.2 miles per hour. And yet here they had many 40 plus mile per hour gusts. So there are many unusually strong winds from that direction. Looking at Westchester here at the Somers site from the New York State Mesonet, their peak wind gust was about 57 miles per hour. They're a little more inland, so they didn't have quite as strong gusts, but they had a lengthy period of 35 mile per hour gusts, in this case about 8 hours, with a little gap in the middle as the storm passed nearly overhead. And again, they had a pretty big range of 35 plus mile per hour gusts. From the east to the south to the southwest, so about a full 130-degree range. Similarly, this is going to be a common theme, but in this case, they only get wind gusts from the southeast about 11% of the time, and when they do, a 1 in 1,000 gust event is only 31.8 miles per hour, which means that if you're getting 57 miles per hour gusts from the southeast, that is an extremely rare event and likely to be quite damaging. Moving up to Putnam County here, we're looking at the Brewster site from the New York State Mesonet. So their peak gusts were about 45 miles per hour from the south-southeast. Again, they had a pretty lengthy period of about 30 plus mile per hour gusts, but they had a little gap in the middle as the storm passed nearby. Similarly, they had another pretty large range from the southeast to the south and west, which is about a 130-degree range. And one thing that I want to note here is at this site, given their topography and nearby elevation and the tectonics, it's quite likely that stronger wind gusts may have occurred in this area that weren't quite measured here, just because of various types of shading in terms of wind gusts. So another common story here, but wind gusts out of the southeast or east are only happen about 13% of the time total. And specifically out of the southeast, and the 8% of time that happens, only 1 in 1,000 gusts is more than 23.4 miles per hour. So that's pretty low. And yet, in this case, they had 45 mile per hour gusts from the southeast. So almost double what a 1 in 1,000 southeast gust might look like. So obviously that's pretty impactful. And finally, looking at Rockland County, and this is from the Southern New York State Mesonet site, they had a peak gust of about 52 miles per hour. They had a brief duration relative to the other sites of 40 plus mile per hour gusts, and in this case on either side of the storm. So they had a peak as the storm was approaching, and then as the storm passed, they had another little peak and then a little lull in between. So because the center went nearly overhead in this case. However, one thing that's important about this site is they had 1.6 inches of rain. So that's what this heavy green line here is. It's a running total of rainfall for this day. And so they had 1.6 inches of rain, and that stopped, you'll note here on this line right here. And basically all of that happened before the strongest wind gust. So they had almost 2 inches of rain in the 24 hours beforehand, and then had 50 plus mile per hour wind gusts, which is definitely going to produce some damage. And finally, for them, only about 7% of the time do the winds come out of either the east or the southeast, 14% total, and only 1 in 1,000 gusts is stronger than 23 miles per hour. And yet they had a 44 mile per hour gust. So again, as with the last case, their gust is about twice as strong as a 1 in 1,000 gust might look like from all of the historical gusts that have happened from that direction. And I said that they had another switch, and they had winds from the west. And they're definitely more common. In this case, they had 15% of the time the wind comes from the west, and that when they do, the 1 in 1,000 event is much higher, about 41 miles per hour. So just want to note that. But they did have a 50 plus mile per hour gust. So one last thing that's kind of noteworthy here is all of this. So this is a map of record strongest wind gusts according to one of the two anemometers at the New York State Mesonet. And this just highlights of when these events have happened. So the record strongest events and when did they happen. And in this case, for all of these sites in this outer pink circle here, all of them set their record strongest ever prop anemometer wind gusts from Isaias. So just as a kind of indication of how widespread and unusual an event is, in the 5-year history that all of this data is coming from, 4 to 5 year history, this is a really unusual event just because it set records for such a wide area here. And this little dot denotes the direction that the strongest wind was occurring from, and you'll see that in pretty much all sites here, it's about southeast. So again, that's a pretty unusual wind direction. So one final thing to look at in terms of the heavy rain is, again, heavy rain was left of the track. So you'll see the track here in purple, and the heavy rain is in the greens and oranges here. And so widespread 3 to 4 to even locally 5 inches of rain. And I want to say again, the heavy rain was always going to be left of the track, and winds were going to be right of the track. So if you want to move that track left or right, you'll get a sense of where the highest winds and highest rainfall is going to end up being. And one little thing here is that, the New York State Mesonet is here to provide added value, is here after Hurricane Irene, and got the money after Hurricane Sandy. And part of the reason for that is because we just didn't have very many observations in critical spots on the Catskills, so we didn't really know what was happening. All we could do is base ourselves on what the radar was telling us and other kind of things. And so what this map shows is what the radar itself says in terms of how much rain fell. So this color bar right here corresponds to what the radar said. And so a green is about 2 inches, an orange is about a little over 3 inches. And then these black dots are what actually happened according to the Mesonet. And all of the black dots mean that that site had more rainfall than anywhere in the state a radar might have estimated. And so all of these black dots basically are saying that the Mesonet here said that there was a lot more rain than we ever would have known about if we didn't have observations in those spots, which is really critical to knowing how much flooding you might expect. So I think with that, I will stop. And as I said, if you have any questions, please contact me and Bassill at albany.edu. And with that, I will stop. Thank you.